Good morning to all. My name is Dr. Janardhana Rao. So, my topic is model in the model process management. We're discussing about thread scheduling and followed by critical section. So, a thread is a single sequential flow of execution of task of a process. So, it is also known as thread of execution or thread of control. So, as we have explained in the previous classes, thread is a part of process. It is a lightweight process. So one task is going on. For one task, there will be number of threads. So there is a way of thread execution inside the process by an operating system. A part of this, there can be more than one thread inside a process. It means that whatever program we have written and that program while execution, this process is has to be executed. That is the program under execution is called process. So for executing one process, there will be number of threads. The sense coming from hard disk to RAM, RAM to your CPU. If CPU it is fulfilled all conditions and it doesn't require any inputs and outputs, then automatically that will be executed and terminated. In case it required inputs and outputs, it will be sent to the waiting queue. It will be in the waiting. So this is it is one thread. This is one thread. Like this, there will be one set at a stage. No process will be executed. So it requires some halts and again resuming the task. So this is called a thread is a part of process. So one thread means one task is there means one task is to be completed. It requires number of threads, number of hearts coming from RAM to your hard CPU, from CPU to waiting state, again from waiting state to ready queue, from ready queue to running state, all these things. So there is a way of thread execution inside the process of any operating system. Apart from this, there can be more than one thread inside a process. So this number of threads required for executing one process. So each thread of a same process makes use of separate program counter and a stack of activation records and control blocks. So whatever update is going on for executing one process, what one thread means coming from RAM to your running state. So there will be one program on stack. There will be one temporary buffer that is maintained. So from stack of activation records and control blocks. So thread is often referred to as a lightweight process. When you see, so one process to be completed, there will be number of threads. That's what we say. Thread is a process of the thread is a part of a process. So rather you can say it is a lightweight process. So thread scheduling. So as we have seen, once the program started execution, so thread started. Thread is a part of process, one process. The process can be split down into many threads. As I told, this is a program and we have written a program. So when you want to execute, this is a program. So when you want to execute, it is coming to your CPU for execution, because CPU inside the CPU there is the ALU. So once you are executing, it is one thread. That's simple, you can say. So one task to be completed means there will be number of threads. So in a single stage, no process will be executed. It requires some steps or some stages. So each stage is a thread, you can say. For example, in a browser, many tabs can be viewed as a threads. So MS Word uses many threads, formatting text from one thread, processing input from another thread. Like this, there will be number of threads for executing one process. So need of thread. So it takes far less time to create a new thread in an existing process than to create a new process. So threads can share the common data. They do not need to use inter-process communication. So context switching is faster when working with threads. It takes less time to terminate a thread than a process. So thread is a part of a process. So it can be easily terminated. Whereas process is a one task. So thread scheduling, the types of threads, as we have seen, there are two types of threads are there. Then one is kernel level threads and user level threads. In kernel level threads, what are the tasks, what are the processes going on, and what is user level threads. So user level threads, the operating system doesn't recognize the user level thread. User threads can be easily implemented, and it is implemented by the user. So as we have seen, while writing a program or doing something by the user, that is user level. So there will be some threads helping the user to implement the task for the user. That is implemented by user only. So if a user if user performs a user level thread blocking operation, the whole process is blocked. So user never try to block the thread operation. The kernel level thread doesn't know nothing about the user level threads because they are separate. So this is user level, this is kernel level. So once whatever user doing, so the threads available for the user, they will help. So once the operation takes over from the user level to kernel, this is the interfacing user level. So automatically, what are threads in the kernel, they will help they will they will be invoked and they will help the user in the kernel mode, because there are user mode and kernel mode. So user level threads help the user, and kernel level threads will help the kernel operations. So that is not nowhere user interfere with the kernel operations. So the kernel level thread doesn't know nothing about the user level threads, because there is a separation between the user level threads and the kernel level threads. So the kernel level thread manages user level threads as if they are single threaded, example Java thread and etc. POSIX etc. So advantage of user level threads. The user threads can be easily implemented than kernel level thread. So user level threads can be applied to such type of operating system. They do not support threads at the kernel level. It is faster and efficient. Context switch time is shorter than the kernel level threads. It doesn't require modifications of the operating system. It is simple to create, switch, and synchronize threads and intervention of the process. What are the disadvantages of the user level threads? User level threads lack coordination between the thread and the kernel. If the thread causes phase fault, the entire process is blocked. So thread scheduling. So kernel level threads, as we have seen, the programs which are the thread programs which are available at the user level, and it will be helpful to the user to implement his user level programs. That is user level. Now, if you look at this kernel level threads. So kernel level threads means kernel is a part of operating system only. That is complete user level or kernel level. That is a part of the complete part is your operating system only. But which programs are helping the user for up to certain extent, that is user level kernel, user level threads. And once the user level thread crosses and hand over to the kernel level, and those programs which are helping the kernel, because these programs are part of OS only. So these programs will be automatically executing inside the kernel or inside the operating system that is not accessible by the user. So these programs are in the kernel. The kernel thread recognizes the operating system. There is a thread control block and a process control block in the system for each thread and process in the kernel level threads. So if one process is being executed, the PCB is created. At the same time, thread control block is also created, because there for one process there will be number of threads. So for number of threads means, so it will create thread control block also. Which thread is operating which thread is helping for the process at what level, what extent, and again the same thread will be used for the other process. So like this, there will be time to time there will be recording, or there will be some monitoring will be taking place, and same recording will be taking place, and this is a thread control block for the process. So the kernel knows about all the threads and manages them, because kernel is the kernel is the one part of operating system. It knows which threads are operating, what is their thread block, and how thread is created, and what thread is supporting at what present which process. Everything record is maintained in the OS while the time of the execution, because user only it will ask, okay, execute or run the program, but later on what is being carried out inside the operating system by the kernel, every minute to minute the operation is being recorded. That is nothing but your thread control block and process control block. The kernel level thread offers a system call to create and manage the threads for user space. As we discussed, most of the system calls will be in the kernel only, because in the previous class we discussed about the write system call and read system call. These are the system calls available in the kernel, because once you want to save a program in the hard disk, and that program will be written in the hard disk, that by using the write system call, because directly kernel will wake up this write system call, and this is written in the program whichever you want to save, that will be written in the hard disk. So after writing the hard, that is nothing but saving. The saving is being taking place. So after saved the program in the hard disk, and that icon is created, and and that will be displayed in the screen. So the kernel level thread offers a system call to create and manage the threads, because system call is a function only. So for executing the function, that system call write function, at a stage it won't do. It requires some hearts also. There are some steps for writing this program in the hard disk. That is, it requires part by part. So each part is a thread. For any system call is basically a function. So for executing this function, there will be number of hearts and steps will be there. These steps are nothing but your thread. So that sentence, the kernel level thread offers a system call to create and manage the threads from user space. What user wants, that will be being executed by the kernel. Inside the kernel, the system calls are there. This system call will make use of your threads. The implementation of kernel threads is more difficult than the user thread. Context switch time is longer in the kernel thread. So thread scheduling, advantages of kernel level threads. So the kernel level thread is fully aware all the threads what is happening in the system time to time. The scheduler may decide to spend more CPU time in the process of the threads being large numerical. The kernel level thread is good for those applications that block the frequency. So disadvantages: the kernel thread manages and schedules all threads. The implementation of kernel threads is difficult than user threads. The kernel level thread is slower than the user level threads. So thread scheduling. The Linux open source operating system or Linux OS is freely attributable. So cross-platform operating system based on the Unix that can be installed in PCs, laptops, netbooks, mobile and tablet devices, video game consoles, servers, supercomputer, and so on. So the Linux OS is frequently packaged as a Linux distributed for both desktop and server use. That includes the Linux kernel as well as supporting tools and libraries. Popular Linux OS distribution include Debian, Ubuntu, Fedora, Red Hat, and OpenUse. So if you look at this Linux, so case studies in the Linux Windows. Windows operating system, computer operating system, that is basically developed by the Microsoft Corporation to run personal computers. Features the first graphical user interface of IBM compatible PCs. The Windows OS soon dominated by the PC market. Approximately 90% of PCs run some version of Windows. The first version of Windows. So if we look at this, the first version of Windows released in 1985. Simply graphical user interface GUI offered as an extension of Microsoft existing desktop operating system. So if you look at this one, MS-DOS based in pattern licenses concept that Apple had used for its machine-to-machine system software. Windows for this first time allowed DOS user to visually navigate the usual desktop. If you look at this Windows and Linux, so we'll see what is process synchronization. So as we discussed so far, the kernel and user. So basically, what is process management? Already you have seen. The process management means there are some programs. These programs available in the OS. These programs will manipulate the CPU. How to execute the program. So how to execute the user program. This is the user program written, and you want to execute this program. So to execute this program, the OS will. This is the OS. Inside this one, there are a number of .exe files. Some programs will work for the process management. Some programs will work for the your security. Some programs for the memory management, like this. So there are certain number of programs, and some of the programs, process management programs. These process management programs will send the program instruction lines one by one to the CPU. This is your CPU for execution. This is nothing but process management. We have seen, we have so far discussed it also, and now we'll see what is process synchronization. So what is for a process synchronization? So suppose this is the program written by the user, and you want to execute this program. You will send these instructions 1, 2, 3. There are instructions in the program. So this is one program. One instruction is sent to CPU for execution. It means the process and execution. Program and execution is called process. Isn't it? So now, one program, one instruction has gone to CPU for execution. So these are other processes. This process 2, 3, 4, and all. They are also instructions. When they go for execution, they are also called process. So there are number of processes available in the program. So when two or more processes operates with each other, cooperate with each other, their order of execution must be preserved. Otherwise, there can be conflict in their execution, and inappropriate outputs can be produced. So as we are discussing, this is one process coming for the CPU for execution, and the other processes are in the queue. So here there must be somebody who monitor only at a time. Only one process should be sent to the microprocessor for execution. So no two processes should be allowed inside the microprocessor for execution. This is called what is the process synchronization. Process synchronization means at a time only one process will be allowed to the microprocessor for execution. So no two processes are allowed inside the microprocessor for execution. So that is nothing but that is called process synchronization. A cooperative process is the one which can affect the execution of their process or can be affected by the execution of the other processes. So it means that only one single instruction should be sent to the microprocessor for execution. So no two instructions should be allowed in the microprocessor for execution. This is called synchronization, process synchronization. If one process is being executed, other processes should be outside in the queue. Still, the first instruction comes out, second process should not be allowed inside the microprocessor. This is soon after the first process comes out, then second process will be allowed inside the microprocessor for execution. This is called process synchronization. Okay. So processes need to be synchronized so that their order of execution can be guaranteed. The procedure involved in preserving the appropriate order of execution of cooperative process is known as process synchronization. So there must be process cooperation between the processes. So one process is executing, other process will be in the queue and be outside of the microprocessor. Soon after, the first process completes its time and comes out. Very next moment, second process will enter into the microprocessor. Microprocessor should not be set idle. So always we make use of that one. So soon after, very first next moment, the another process should enter into microprocessor execution. This is cooperation between the two processes. One will be one soon after one comes out, another will enter inside this one. So no two processes should be permitted to inside the microprocessor. This is what we call it cooperative process. So what is in the process synchronization? We will find certain terms. One is the race condition. So race condition, and second one is critical section. So what is race condition? A race condition typically occurs when two or more threads try to read, write, and possibly make the decisions based on the memory that they are accessing the concurrently. So whether it is race condition means suppose one shared memory, one memory is there. So no one process is just we are writing it. So when it is writing, when write operation is taking in the memory, so another process should not disturb that one till the writing completes. So that's what. So other process should not enter or read or try to read or write anything in this one. Once one operation is going on, that other should not interfere with this operation. That's what we call race condition. If more than one process is trying to approach either a critical section, either your microprocessor or a shared memory, so then there will be problem. There will be ambiguity. So this is called race condition. A race condition is typically occurs when two or more threads try to read or write. So only one thread is permitted. No two threads or two processes to enter into the this memory, shared memory. So they are concurrently. They may access concurrently, one by one. So one operation should be completed. Suppose one write operation is taking place, till the write operation is completed, other process should not be permitted to read it, because if it is writing is going on in between, if you read operations are also happening, though half is correct, half is wrong. So that operation must be completed fully. That the write operation should be completed fully, then only read operation will be permitted, should be permitted. That's called race condition. No two processes are permitted to enter the shared memory at a time. At a time, we should not allow to. Same. Now, what is critical section? The reason of a program that try to access shared resources and may cause race condition are called critical section. So, as we discussed, shared memory sharing means your CPU is sharing, CPU under sharing only, because one will be using after this one, another will be using this is sharing. Like this, some memory is there. This is also. So one process can make use of this one, other process will make use of this one. So what is that sharing? So this is shared resources. This is one resource and this is one resource. These resources will be shared by the processes at certain time. So it means we should control them. Only one will be using at a time. We should not permit it. Two processes will use this shared memory at a time. That's what if they want to use at the same time, then it will be causing ambiguity, and further there will be a disturbance in the operation. So the critical section is a simple example. If some process is using the microprocessor, other process should not interfere. It should be in the outside only, outside the queue, outside the microprocessor. So it should not try to enter into the microprocessor for execution. That's what say. That is, if two processes are trying to enter into the same microprocessor for operation, so microprocessor will be confusion. Whom it should handle. So the operating system must try to send one by one. That is called critical section. So to avoid race condition among the processes, need to assure that only one process at a time can execute within the critical section. That's what we are discussing. So as we are discussing only one process must be permitted to enter into the microprocessor or shared memory at a time. So this is very quite clear. This will see what is the critical section. The critical section problem. The critical section is the part of program which tries to access shared resources. The resource may be any resource in a complete computer like a memory location, data structure, CPU, or any variables. So critical section cannot be executed by more than one process at the same time. The operating system faces the difficulties in allowing and disallowing the process from entering the critical section. The critical section problem is used to design a set of protocols which can ensure that the race condition among the processes will never arise. In order to synchronize the cooperative processes, our main task is to solve the critical section problem. So by the time you must have understood what is critical section. Critical section means that is common area. The common area, maybe a memory, maybe IO, maybe a CPU. So these are the this will be used by the processes at the time of execution. So it means that very meaning is critical. It means very critical. If two processes are entering into the microprocessor cannot give the attention to one process. So no two processes should be allowed in the microprocessor at the same time. So that memory location. Suppose there is a data available at some memory. This is memory. Some data is available. So this may be whether it's writing or reading this one at a time. One operation will be allowed. Either read operation or write operation. We had discussed in the previous slide. So if one process is writing, so other process should not allowed to enter in this common area. So once the writing completed fully, then second process will be allowed to read it or write it anything. So that's what no two processes at a time should be allowed in the common premises. That is our maybe CPU, maybe data structure, memory, or IO device, IO operations. So only one, not two. So if two are trying to enter or want to use the resource, so the operating system must stop it, avoid it. It should give access to only one process at a time. That is called this process cooperation, or and you can say that is a problem for the critical section. So in order to synchronize the cooperative processes, our main task means operating system main task is to solve the critical section problem. So the critical section problem. So different approaches are there. In this one, the critical section problem is to design a protocol that processes can use to cooperate each other. Each process must request permission to enter the critical section. The pseudo code for the mechanism tools looks like this. So this is entry section. While lock is not there, lock is not 0, then lock it. Lock is equal to 1. Make it lock it 1 and do the operation. So next exit section. Again lock, make it lock 0. So in the above pseudo code, there are 3 sections in the code: entry section, critical section, and exit section. So if the CPU is free, this is your CPU, this is CPU. So once CPU is free, then enter inside this. This is the entry section. So make lock 0. Make lock 0. That is here under the CPU. So now it is running. Now it is running there. So after running, come out, then unlock it. This is there are 3 parts in this critical section. One is entry section, critical section, and exit section. So it means that once lock is there, the other process cannot enter into the critical section. That's what main part. So once lock is there, no process tries to enter. That is running state. So exit means once the process exits from the CPU or shared memory, then unlock it. So other process will enter again, and while entering, it will lock it, and running. It will do the operation. After operation is over, then unlock it. This is what simple code. Initially, the value of lock variable is 0. The process which needs to get into the critical section enters into the intersection and checks the condition provided in the while loop. So critical section problem, there are a solution to the critical section problem must satisfy the following three requirements: mutual exclusion, progress, bounded waiting, portability. So out of the four parameters, mutual exclusion and progress must be provided by any solution. Let's analyze this mechanism on the basis of the above mentioned conditions. So the critical section problem, we'll see these critical section problems in the next class.
Like, share and subscribe. Hit the bell icon for more updates.